Can I? Whoa. Can I start? Yeah, so good afternoon, guys. Uh, Thank you for coming to my fireside. I'll be talking about terminal user interfaces. So, like tools like HTOP, BTOP, all that. You know how I'm gonna be going through how everything works, like how it's built and how it actually runs behind the scene, right? So basically, as usual, one night I was browsing Reddit, as one does, and I came across this post. A rice, school rice, okay. But I saw it's all terminal. There is like a task manager here. There's nvim here, obviously. It all got me thinking. Right, this everything is running on a terminal. There is no framework. There's no electron. Who likes electron, anyways? There's no electron, and there is like anyway. There's no framework. It's all in a terminal. I wondered how it works. And here's where TUI comes in. A TUI, or a terminal user interface, is basically a full-fledged app that runs in your terminal, and it's rendered completely with characters and escape sequences. So you might think, see, CLI apps, LS, everything that works in the CLI. How is that different from a TUI? Well, basically, a TUI is a continuous app. LS or any other terminal app will just take the input and just spit the output out. But a TUI will just work like a normal app. It will continuously be running and it will give you input, output, everything. Right? So how does that work? You saw a screenshot right here, right? How does it gets rendered? So a TUI is basically, can think of it as a huge array, a 2D array or 2D buffer with rows and columns. Each row and a column is a character, and each character is filled with ANSI codes. ANSI, or American National Standards Institute, is an institute that sets programming standards, and one of them is the ANSI escape codes. I'll talk about it a bit later. So basically, how is the rendering working? First of all, your TUI app has the rows and columns, all the characters, right? Say in a TUI app, there's some change in one of the graphical elements, right? That change is given through escape sequences that goes to the PTY, or the pseudo terminal. This I'll talk about this tool later, and this pseudo terminal will give it back to your terminal emulator or your PT, Alacrity, whatever it is, right? That's what's happening. Here you can see same thing here, as in HTOP, right? Only this part is changing. Basically, you can think about it. So there's no buffering or anything, or there's no flickering of the screen, because only that part is changing. The rest of it is the same. So that part of the 2D array is changing, right? So here's a few ANSI examples. You can try it out on your own also. Like this, it's as ANSI escape sequences. So escape. So each code starts with the escape, which is in hexadecimal /x1b. Did it? Oh, right. Wait, I'll use PESU Wi-Fi. Wait. No, I'll use hotspot. It's fine. That should be better. Are we back? Yeah, I guess you're back, no? Yeah, so as I was saying, a few ANSI examples. One of them, you can try it on your own. Here, right here is just getting the text, making it red, printing the text hello, and then converting that red back to black after the hello is printed. I am, no. I was. Oh, wait, sharing. Hey, fine. Do I need to go back or continue? Okay, I was saying ANSI codes. These are some of the example codes. You can try it out. Echo. This just makes the text red, prints, gets the text hello. Then since it's already red, we're gonna convert it back to the default. So this is making the text default again after the hello is printed. Right. So I was saying PTY. Remember the pseudo terminal. Basically, any CLI app or anything that happens in a terminal goes to this PTY. So what is this PTY? PTY, or the pseudo terminal, is a fake terminal device. Now, why is it fake? Basically, back in the day, when the beige computers and all, There was a terminal referred to an entire computer. No, there was a keyboard and a monitor that was connected to some computer. Whatever you typed in the computer would be the terminal and would change. But right now we don't have this. We have actual GUI computers. So this PTY emulates that basically. So when you say you're printing to STD out or taking input from STD in, basically you're going through this PTY and getting your stuff back. So here in 2 basically any terminal interface, you're gonna get any or that standard out ANSI bytes. It's gonna go through this PTY and come back to your terminal emulator, right? And now, how do we input stuff? How does a TUI input stuff? And for that, you need to know about raw mode and cook mode. So, your terminal emulator or your Kitty or Alacrity or any other XSC terminal, that's in cooked mode by default. So, which has buffering. Buffering is, so you type a huge command, you type like ls, some folder, then some other flags. All that is buffered into one string, and then that's given to the program. But in a TUI, we don't want that. No, in a TUI, if you press up arrow, we need the thing to immediately go up. Or you press some key, we need it to immediately go down. So we switch from cook mode to raw mode. As you can see, raw mode gets you the raw bytes. Each input is associated with a bunch of bytes. So up arrow is some bytes. As you can see, delete key is these bytes, home key is these bytes. So, or many more of every other key. These bytes, we take them and we use those to that input from the terminal or from the TUI. So here's what's happening. You press any key in your TUI app, it goes to your terminal emulator. Your terminal emulator gives it to the PTY. The PTY, your TUI app reads it from the PTY, sends it to your terminal user interface, and then that interface calculates, or your program basically parses what that thing should do. So up arrow should move the element up, whatever. It gives and makes the event. Yeah, so here are some practical use cases. As I was saying, Arch install and Bashtop. I guess heard of Bashtop? No, it's basically HTOP but better, and low-end hardware support. So if you have a really old PC, rather than using many GUI apps, you can have one browser and everything else you can run it through your terminal, right? So here's some trade-offs. Obviously, nothing can be perfect. So you can't really make all this GUI is right. It depends on your terminal emulator. As you might know, Kitty, the most famous terminal emulator, is hardware accelerated. So some other terminals like XSE4 terminals are not hardware accelerated. So it depends on that. Some programs need hardware acceleration, some programs don't. One more thing is, have you guys heard of aliasing in games? Basically, your computer or your screen is pixels, right? It's just blocks. So to create a diagonal line, it's going to be pixel, 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 which it doesn't feel smooth, right? Anti-aliasing software in GUI, we can do it, but in TUI, it's more difficult to have smooth lines. That's one thing, and of course, it's like more overwhelming. You don't know what to do. You're more used to GUI apps, right? So you don't know how to take inputs and such properly. Yeah, that's what it. Thank you, guys. Any questions? Any questions? Yeah. I use Kitty, the best one. Also, it's Cat Kitty. I used to use XSC4, but then I wanted a hardware accelerated terminal, and I wanted a terminal that it renders images. So Kitty. Hmm? Kitties? Oh. Oh, I did not know that. Oh. Oh, that's nice. I did not know that. Oh, yes. Yes. Yeah, yeah. Yeah, yeah. You don't really need a buffer. Maybe when you have search in HTOP, maybe that's buffered, but that's again inside the TUI. You don't need buffering when you're taking inputs from the TUI, from the user into the TUI. Thank you, guys.